Hello and welcome to our project presentation, Conditioned Cocktails, Modeling Substance Use Disorders Through Machine Learning. So our presentation is going to be structured in the following way. I'll introduce the team of the project, and then Vinay will discuss our model and method. AJ will then discuss and display our product demo. Then we'll pass it back to Vinay to discuss some limitations of our results. And finally, we'll discuss some future endeavors for a project or tool like this one. I would like to call out that at the bottom here is our project required questions that will be answered throughout the presentation. So I'd like to take a second to introduce our team, Conditioned Cocktails. Our team consists of 3 members, Vinay, AJ, and myself, Zach Banta. Our team is approaching Challenge 2, which is to investigate medical conditions indicative of underlying substance abuse disorders. Our approach has been to identify medical condition groups present in longitudinal patient records and utilize the presence of those conditions as features for our machine learning model. The model produces a risk score as well as risk factors for each patient. So now I can pass it over to Vinay to discuss our model and method.
Our implementation starts with pre-processing of LPRs to obtain medical diagnosis codes and explore the distribution of codes, followed by machine learning model selection and evaluation. For preparing the dataset, we have come up with 22 different ICD-10 code groups and obtained condition count for each code group. Coming to data exploration part for substance abuse disorder patient records, the highest code count is associated with mental, behavioral, and neurodevelopmental disorders. Also identified that prenatal codes are not present to any given patient record. For non-substance abuse disorder patient records, more than 50% of the code distribution is spread across diseases related to immune mechanism, genitourinary system, and Z codes. In terms of data correlation, the ICD-10 code subgroups that are predominantly present in patient records are highly correlated with the outcome. Surprisingly, mental health codes are not extensively correlated compared to other code groups. For modeling the data, we have designed a pipeline that shuffle split the data and standardize it before training the model. We trained 3 models using logistic regression, decision tree regression, and random forest classifier. Performance of all these 3 models is almost the same with high precision and recall scores, which indicate that the model is able to classify the substance abuse disorder patients with minimal error. After analyzing the feature importance scores, it is evident that the diseases related to immune mechanism, generic Z codes, and mental and behavioral codes contribute to almost 50% towards the substance abuse disorder risk. Now I will let AJ show a web application that uses this model that could predict the risk scores of a patient.
Today I'll be demonstrating a web-based app we built that clinicians can use to get an overview of their patients at risk. The mock data displayed in this app would be fetched from a Python backend which does the risk analysis with our machine learning model. The dashboard includes patients flagged by our model at a significant level of risk and how many patients completed a health questionnaire related to risk factors. You can view how many patients are at each risk level in the bar graph, and the cards to the right emphasize those most at risk, sorted by descending risk score, and noting their next appointment time. You can search for a patient by medical record number using either the search bar, or you can go to the patients page where you can see the risk scores that are color-coded by risk level, and clicking on a score will bring up the patient's risk analysis. For this patient, we list her conditions and how much each was weighed towards the total risk score calculated by our model. In the More Info tab, we present 3 risk factors that contributed the most to this patient's score. In summary, this app presents our risk analysis to the clinical user in a clear and simple way that brings attention to patients who have the highest potential to falling victim to substance abuse.
Our methodology does have some limitations. The distribution of the data used for a model does not mimic the real world data. ICD-10 codes alone does not provide the entire information of the patient. Our model have very high accuracy scores on the given dataset. However, it is not certain that the same results will be replicated on real patient records.
So in terms of future endeavors, a web-based application is a great tool, but we'd also love to enhance interoperability with other tools and applications. The design of this system is simple enough to be integrated into patient or provider portals, EMRs, etc., while also being important enough to add value. The enhancements and applications of this tool really are endless. So from all of us at Condition Cocktails, I want to say thank you for enjoying our presentation.